Let's work on solving this triangle. So with this triangle, we're given an angle side case for a triangle. We don't know it's a right triangle. You can see we have an angle, another angle, and then a side given to us. So being that we don't know that it's a right triangle, that we have a 90-degree angle, we're kind of limited on how we have to approach this. We can either use the law of sines as listed over here on the right-hand side, or perhaps the law of cosines, just based on the information that's given. We can use either one of those when we're given any triangle, but specifically when we don't know that it's a right triangle. Okay, so as we're trying to solve this, find all the angles, all the side lengths. The first thing that I may go ahead and find is beta. Okay, so beta, that angle, we know that all the angles in a triangle always add up to 180 degrees. So that calculation would be, we can take 180 degrees and we can subtract away the two angles that we know. We know alpha and we know gamma. So with that, we can tell that beta is going to be 100 degrees. And I'll kind of label things as we go. 100 degrees in this corner. And we can label this as side A. A is always across from angle alpha. B is always across from angle beta, and C is always across from angle gamma. All right, so as we get going on the rest of this, we still need to find B and C. The only obvious choice to go with is we know both of the A's, or we can say side A and angle alpha. So what I want to do is use angle gamma and find side C. So I'm going to use this bottom version of the law of sines, where we can say that C divided by sine of gamma, 30 degrees, is going to equal, I'm going to use the A's. So side A over sine of 50 degrees, because that's what we have for angle alpha. All right. And I use this version because it's just going to be slightly less as far as our steps go to be able to solve down and get C on one side by itself if it's already up in the numerator. All right, next, what I'm going to do is go ahead and multiply to get rid of the sine of 30 degrees from the denominator. So I want to multiply the left-hand side by sine of 30 degrees and multiply the right-hand side by sine of 30 degrees. That makes a 1 and cancels out over on the left-hand side. So we're going to have C on one side all by itself. This sine of 30 degrees, you can visualize it as being up in the numerator with the 10. So to get this calculation, we want to make sure that we're in degree mode, because these are in degrees for angle measure. Do 10 multiplied by sine of 30 degrees, maybe close some parentheses off, divide by sine of 50 degrees. And I got C is going to be 6.5 units. We were asked around to the nearest tenth. Go ahead and label our triangle, make sure that we're kind of keeping track of everything. The very last thing we want to find is B. We don't know side length B. So to find that, I'm going to set up, again, a law of sines type of problem. So I'm going to say I want to find B. Well, I have to put that over sine of 100 degrees, beta. And I can say that's equal to either 10 over sine of 50 degrees or 6.5 over sine of 30 degrees. I'm going to go with the A. So I can say 10 over sine of 50 degrees. Again, our solving down shouldn't be too bad on this one. I chose this version because B is up in the numerator, a little bit less as far as the steps go to solve down. Very similar to what we just did on the left-hand side. I'm going to go ahead and multiply both sides by sine of 100 degrees. That will get B on one side all by itself. I'm going to enter the right-hand side into our calculator, making sure we're in degree mode. And I got 12.9 units on this side. So that takes care of it. We've solved the triangle. We found all the side lengths and all the angle measures. So I hope this helps out as you're working on law of sines. Good luck.